if you need it. Okay, so we'll go through part of graph 1 together, okay? So our initial graph looks like this, okay? Just typing in this graph straight away is not going to help us understand it very well. So I've broken it down into different pieces for us, okay, to see how each piece changes. So first it says graph f of x equals sine of x. I'm going to go to my Desmos graph. And I'm going to type in f of x equals the sine of x. Okay, and I should get this graph over here. Okay, so even if you don't have this paper, you should be doing this Desmos part along with me. Let's go ahead and change some settings so that it's easier to see the function. Okay, so if you go to the little wrench on the side, settings should pop up. Okay, and on the x-axis, I want your step to be at least pi over 2. Okay, so type in pi and do a little space and it should come up with a pi and then do the forward slash and a 2. Okay, that'll make, if we look at our graph, that'll make our x-axis have intervals with pi in them. And I think that's all we really need for this. Okay, make sure your axis numbers, your minor grid lines, and your grid are highlighted. Okay, is everybody up to speed? Does anybody need a minute? What questions do you have?
Was the step over 2?
So go to the wrench and type in pi and then over 2. Pi over 2. Let me let in Amani. Her screen keeps freezing. Okay, did anybody have trouble doing that? Okay, so you guys should have that. The next step on this investigation says to graph the sine of 2x. Okay, so we're going to basically see what this 2 is doing in here. So we have f of x equals the sine of 2x. Okay, so what happened? What do you guys think changed there?
The periods became more frequent.
Yeah, good, Heath. So our amplitude is the same, right? The same height, same minimum. Our midline's the same. They both hit their midline point at the same time on that axis. Let's see what else was in our vocabulary. Our amplitude is the same. Our phase shift is the same. They both start at 0. So the only thing left is our period. This 2 changes our period and it makes it more frequent. So Heath, since you answered that question, is it a shorter period or a longer period than the original?
It's shorter.
Right. So what is the period for this one going to be?
Just pi.
Good. So the period for this function is pi. Okay, so you're going to write pi in that little blank. If you're doing this on notebook paper, I don't really expect you to have any of these words up here. If you want to draw the paragraphs, you can. If you're doing it on notebook paper, the things that I definitely need you are to include this full expression for a function expression for the first graph. Then write out the steps and make sure you have the answers to each of these blanks in there. Okay. So then the next step is to graph sine of 2x minus 1. Okay, so I'm going to have f of x equals sine of 2x and then minus 1. Okay, so let's see, who hasn't said anything yet? Dahlia. What changed between the blue and the green graph? Dahlia, are you there?
Yeah, sorry. I would try to bring up paper.
That's okay. So were you able to see what I did on the Desmos thing?
Yes, I understand.
So the next step was to graph f of x equals sine of 2x minus 1. So we added a minus 1 onto our function. So now my question was, what happened? What's the difference between the blue and the green graph? What changed there?
The amplitude, it went down 1. Right.
So I see what you're saying. It's easy to say that the amplitude went down 1, but remember that the amplitude is the distance between the midline and the max, or the midline and the min, okay? And the midline here is at -1, and it goes up to 0. So the amplitude here is still +1, just like the amplitude in the blue one was +1. So maybe something else changed. What do you think changed?
Then the minimum and the maximum.
So yeah, they're at different places. And why did they move to different places?
The range changed. Like it
So if we look at our vocab, we decided amplitude doesn't work because we looked at the amplitude and they were the same. Okay, so that leaves midline, period, and phase shift. So is the period the same? Does it take the same length of time for the blue and the green to finish one full cycle?
Yes.
Yes. So period didn't change. So we can cancel out period, cancel out amplitude. Phase shift means that I should shift, the green should be shifted to the right or left from the blue. Is that the case?
No.
No. So it can't be amplitude, it can't be period, it can't be phase shift. So the only thing left is midline. Okay, so this midline shifts it vertically up and down. So did it go up or down? Did the green go up or down from the blue graph?
It went down.
It went down. Good. So our midline changed. So our midline, we go over to the front, or it asks for the vertical shift, should be down 1. You could also write -1. That would be fine. And it says draw the midline at the correct height on your graph. So the midline should be y equals whatever the number is for our vertical shift. So -1. Okay, so maybe I would make -1 maybe here. And we know that our midline is going to pass through right here. This is like the first definite thing on our graph that we can draw in. We have a midline at -1. Okay, so it is 9:45. We have not finished all the way through, excuse me, this particular example, but I think that you guys probably have the idea of what you're supposed to be doing for each of these steps. What questions do you guys have before you start?
Did you want us to draw out everything you just did on this little graph on the side?
So the only thing that needs to be drawn on the graph at this moment is the midline, because as we add things to our function, it's going to change its location and how it's drawn. The only thing so far that's definite is the midline. We know that the midline's at -1 for the final graph. So that's why we've only drawn in that piece of the final graph. So it'll tell you on the investigation, like it didn't say to draw any of that stuff on the graph up here. So just don't draw it, just answer the questions and just have them up on Desmos. And then as it tells you to draw the graph, then draw it. Let me see what the final, so it says it asks you about the amplitude, then it tells you to graph the full thing, okay? So once you've gotten the amplitude, you should have your final graph in here and you'll be able to draw it on your paper. So it's just the final graph that you want to draw. If I wrote up here, if you do want to draw all the intermediate steps, like if you want to start with the red one and draw the blue one and draw the green one and then have a particular color for your final answer, that's fine. Just use a highlighter or some sort of color to like show me like that your pink graph is the final one and that maybe you have like the orange graph as your initial step. So that I can see what you intended to be your very final graph and what you intended to be an intermediate step. Does that answer your question, Ruby? Okay, sorry, that was kind of long-winded. Any other questions?
I assume we do all the graphs.
Yes, so you'll do all the graphs, all 4 of them, and then we'll go through this summary part at the during next class. I was going to say at the very end of class. We'll do the summary together next class, so you don't have to fill that part out. Okay, what other questions do you guys have? Okay, so for today, you are working on this investigation during your asynchronous time, and then you are redoing your homework, and that is all. Is everybody clear on what needs to be done for today? Okay, I hope that everything's clear. If everything's not clear and you have a question, please feel free to stay on and let me know. But you guys are all free to go. Sorry I kept you 4 minutes.